Well, thank you for joining us for today's webinar, What's the Latest Science Say About Living Longer, Healthier Lives? This webinar is part of an ongoing partnership between the UAB National Alumni Society and the UAB Office of Planned Giving. I'm Greg Berry, Assistant Director in the Office of Alumni Affairs. Just a quick note, since we're virtual, don't be surprised if something may be out of place from time to time or technical issues pop up. If you have any audio or video issues, click the reconnect button at the top of your screen. That will get you back into the webinar quickly. Today, we're going to be digging deep into geroscience, and as we find out how it studies the biology of aging, looking for ways to treat the aging process as one would treat a disease. But before we introduce today's guest, I would like to ask you a question. How familiar are you with geroscience? Your options include three things. You're on top of all things geroscience. You're an expert. Maybe you are somewhat familiar, but interested in learning more, or perhaps you're a geroscience rookie and are excited to be introduced to this new topic. I'm going to go ahead and keep the poll up for a few moments so you can submit your answers. At the end of today's presentation, we will have time to get to your questions. So please drop those into the chat box and we'll make sure they get asked. So the poll, here's where we're at. Nobody's an expert. Pretty much nobody is an expert. There might be one or two people that filled that out. Most of us are a rookie into this science with 59%. 40% knows a little, but they're looking to learn a little bit more. Well, at this time, I would like to introduce Kimberly Kopic, Director of Development for the UAB Office of Planned Giving, to introduce today's guest. Kimberly.
Thanks, Greg. Good afternoon, everyone. It's my very great pleasure this afternoon to introduce our speaker, Dr. Stephen Austad. Dr. Austad is a distinguished professor and the chair of the Department of Biology at UAB. He's also a senior scientific director of the American Federation for Aging Research, a New York-based national philanthropic organization. With an undergraduate degree in English literature and after-work experience ranging from New York City taxi driver to lion trainer for the film industry, Dr. Austad received his PhD from Purdue. He accepted his first faculty position as assistant professor at Harvard University. He then took his talents to the University of Idaho, and then to the University of Texas Health Science Center, San Antonio, where he became the director of the Barshop Institute for Aging and Longevity. Luckily for us, he then took up his current position at UAB in 2014. His research encompasses many aspects of the biology of aging. His specialty is the identification and study of non-traditional species for insight into the processes of slow aging. His research has won many awards, including the Geron Corporation Samuel Goldstein Distinguished Publication Award, the Nathan A. Schock Award, the Robert W. Kleemeyer Award, the Purdue Outstanding Alumnus Award, and the Irving S. Wright Award of Distinction. With an abiding interest in communicating science to the public, he has served on the Scientific Advisory Board of NPR and written more than 150 columns for newspapers and national electronic and print media. His trade book, Why We Age, has been translated into 9 languages, and his forthcoming book, Methuselah Zoo, The Natural History of Exceptional Longevity, will be published in late 2021. Dr. Austad, we are so excited to have you here with us this afternoon.
Well, thank you, Kimberly, and thanks for that great introduction. I hope I can change the poll numbers over the course of this talk on what geroscience is. And welcome to all the alumni out there. I'd really like to say that something's been going on here at UAB. It's been a stealth development, and that is that over the past few years, UAB has really emerged as a national powerhouse in the science of geroscience, and I'd like to tell you a little bit about that. And this is a campus-wide development. It not only includes the College of Arts and Sciences, where I'm based, in the Department of Biology, but also the Medical School, the School of Public Health, the School of Health Professions. It's a campus-wide effort to find ways to keep us healthier longer. So let me just proceed a little bit and start my story about a year ago. About a year ago, the Wall Street Journal approached me and asked me if I would be willing to write an editorial defending the proposition that 100 years is the new life expectancy for people born in the 21st century. Now, I have to tell you, that's a pretty radical statement, because right now, only about fewer than 1 person in 1,000 lives to be 100 years of age. But here I'm making a claim that the people that were born in the year 2000 or later, that is most of the college students that I teach these days, can expect to live 100 years. And I'm going to spend the whole rest of my talk explaining why I think that's quite feasible and quite conceivable. And I'd like you to just think as we go along that if you could choose, how long would you like to live, given what you know about the way life proceeds now? And we'll probably come back to this at the end of the talk. Now, right after I wrote that editorial, you notice by that date that was a month into the COVID-19 pandemic. And at that point, we didn't know if it was how serious it was going to be. It turned out to be, of course, pretty serious. So here we are a year later, and people have asked me, well, did the emergence of COVID-19 change your opinion about how long people are likely to live in the future? And I'm happy to say that even though it's had a big impact this year, life expectancies dropped more than a year in 2019, 2020, or 2020, 2021. The long-term effects look not horrible at all. It turns out that, in fact, it's going to be one of the breakthroughs that I think has been our response to COVID that suggests how in the future we're going to have less and less a problem with these emergent infectious diseases. Now, one of the things that COVID did, though, is it emphasized something that everybody that studies aging knows, which is infectious diseases are much harder on older people than they are on younger people. And you can see in this graph here, this is the specific death rate. That's the number of people per 100,000 of a certain age that die due to COVID-19. And this is one of the reasons, of course, that the priorities for the new vaccine were to treat the older people first. But what I'd like to point out about that is that it's really no different than the effect of influenza. It's more deadly than influenza, but the pattern where it hits the older people hardest is pretty much identical. In fact, if I put on the same graph the death rates as a function of age for cancer or heart disease or even Alzheimer's disease, they look pretty similar to that. So there's something that goes on in our bodies, which is what geroscience is trying to understand. It's not magic, it's biology that's going on inside of our bodies, and we're trying to figure out how we can treat that as if it were a disease, like Greg said. Now, I'd like to present some good news. Most of this talk is going to be great news, by the way. Occasionally, I'll mix in a little cautionary tale, but it's mostly good news. And here's the first bit of good news. Since 1900, life expectancy in the United States has been increasing by 66 hours per day. Think about that. That's over a 30-year increase in life expectancy since 1900. That means if you make it through the rest of my talk, you'll probably increase your life expectancy by a few hours, or at least a few minutes, just for that. Now, I don't think this is at an end. I don't know if this trend is going to stay linear like it is now, or if it's going to change a little bit. But I'd like to point out that Japan, the longest lived country today, is already quite a ways ahead of us, and I see no impediment for us eventually catching up to Japan. Japan, by the way, Japanese women live on average 87.5 years, and the most common age at which Japanese women die is between 91 and 95. So that shows you the direction that health is moving. Now, that's because of better medical treatment, of course, better nutrition, cleaner water, all those public health measures that have really driven this increase in life expectancy over the past century. Now, I'd like to make as vividly as possible to you how dramatic medical progress has been. So what you're looking at here is you're looking at the decrease in all of these diseases that's happened just since the year 2000. And you can see that there's been about a 35% decline in deaths from heart disease since the year 2000, even a little bit more in stroke, and quite a dramatic drop in flu and pneumonia deaths. So that's very, very good news, and it shows how successful our medical enterprise has been. However, we've been a little bit, I guess, victimized by our own success, in that one of the consequences of that is that we're living longer than we ever have in the 300,000-year history of our species. And our bodies have not really been designed to live that long. And so the great medical successes have been accompanied by increases in frailty, disability, and dementia. And you can see there the increase in the number of people living in nursing homes and the number of people suffering from Alzheimer's disease. So that's some not so good news. Now, what I really want to do now is make in a way that's more vivid than I hope you've ever seen before why I consider aging to be the #1 threat to human health today. It's not heart disease, it's not cancer, it's not osteoporosis, it's not Alzheimer's disease, it's aging. And let me make that very, very vivid for you right now. Now, what you're looking at in these 4 bars is you're looking at the percent increase in deaths from heart disease as a function of these lifestyle factors. These lifestyle factors, or this disease brought on by lifestyle factors, that the National Institutes of Health is spending billions of dollars trying to figure out how to improve. We've already found lots of ways to improve hypertension. That's one of the reasons for the drop in heart disease and stroke. Fewer and fewer people are smoking. We have cholesterol lowering drugs, and more people are paying attention to their meals. But let me put all of these risk factors in context for you and show you what they look like in comparison to the increased risk of aging. There they are. So aging dominates, massively dominates all of these other risk factors for heart disease. Let me give you a second example. Same thing for cancer. Cancer risk is increased by smoking, of course, by excessive alcohol consumption, by diet, by certain infectious diseases. Again, how does cancer look relative to aging? There it is. You can barely see any of those bars still. And the last example I want to give here is perhaps the most impressive, and that's the example of Alzheimer's disease. Now here, they're slightly different. First of all, don't get excited about sex increasing your risk of Alzheimer's disease. What that really means is that the sex, your sex, whether you're male or female, has an influence on your Alzheimer's disease. This is the only one of the top 12 causes of death to which women are more susceptible than men. It's something we don't understand, but something that a number of us are very, very interested in. One thing I'd like to point out is this big bar, ApoE. This is the only genetic risk factor that I've got in this, but this is a gene that's carried by about 1 out of 6 people, and if you have a copy of it, doesn't mean you're going to get Alzheimer's disease, but it increases the probability by about 5-fold. And if you have 2 copies of it, and that's only about 1 to 2% of the population, then you have a 10-fold time increase of getting Alzheimer's disease. Well, again, let's take all those risk factors and see how do they look compared to the impact of aging on your risk of getting Alzheimer's disease. And here's the answer right there. In fact, you can't even see any of them. They're all there still, but the only one that you can see just a little bit of is the genetic risk factor. So when I say that aging is the #1 threat to health, it's because it underlies all of these diseases and more. This is good news, bad news. The fact that we're living so long means that more and more people are wearing out their joints, and their joints need to be replaced. The bad news is their joints wear out. The good news is we can do something about it now. And as you can see, we do about 1 million of these a year in the United States. And then there is all of the other things that we're not talking about: the arthritis, the frailty, the osteoporosis. You put all these things together, and I hope I've convinced you now that aging kills and debilitates a lot more people than any other cause. And it's something we tend to forget about. Nobody ever says, oh, I'm so sad that grandma passed away from aging. We think, well, grandma passed away from heart disease or Alzheimer's disease or something. But in reality, all of those things, you could make the case that it's really aging is to blame. So what I'd like to do now is describe to you a new kind of medicine, a 20th century medicine, a 21st century approach to health. And I first of all like to start by describing what I call 20th century symptomatic medicine, and that's shown by these silos. And if you think about it, this is how we think about health today. We think about, well, how's our heart doing? Are we getting cancer? Are we getting Alzheimer's disease? The medical specialties are set up like this. You have a cardiologist, your oncologist, your neurologist, your pulmonologist, your infectious disease specialist. Maybe you have an audiologist and a diabetician as well. Even medical research is set up in this way. The National Institutes of Health, I could replace each of these names with the name of one of the institutes. We have a Heart Institute, we have a Cancer Institute, we have neurological disease and stroke, we have pulmonology. That's the way it's set up. Now, a couple of decades ago, those of us studying aging pointed out to the medical community that, you know what? What underlies all of those things is the basic process of aging. And that's really what we need to be focusing on. Because once you get cardiologists and oncologists to start talking to one another, they realize that a lot of times they're talking about the same things. They're talking about processes that are understood these days to be part and parcel of aging. And the science of the geroscience is really a new word that describes how aging impacts all of the diseases that kill us, the diseases that disable us, the diseases that just degrade the quality of our lives. So I'm going to briefly mention just 5 what I think are major developments in this field. And these 5 things could all have an impact on people that are listening today. So you may have heard of some of these. I doubt if you've heard of all of them. The first one, I think, is something that you may not have thought about yet, but that has to do with exactly what we're experiencing right now. You know, a year ago, we were hearing horrific things about how long it might take to develop a vaccine, to manufacture that vaccine, and to distribute that vaccine. And yet here we are a year later, we not only have a vaccine, we have 3 or 4 vaccines, and we're shortly going to have enough vaccines to vaccinate everybody in the world. Already, of course, in the US, more than half of adults have been vaccinated. And that's because these are new kinds of vaccines. These mRNA vaccines are brand new. They can be developed very quickly. And the good news, where the breakthrough is that they're very easily modified to go after a new disease or a new variant. And you may have heard that one of the likely outcomes of COVID is that some of these new variants are going to mean that a year from now, those of us who have been vaccinated may have to get a booster. And that booster may be a slightly different mRNA to go after a slightly different variant, but it's very easy and straightforward to produce. We know how to do it. Even the Johnson & Johnson and AstraZeneca vaccines, which are very similar in the way they're done, they're also able to be repurposed very quickly. So that not only means that we've rapidly been able to do something about COVID-19, but we're going to even more rapidly be able to do something similar when the next disease and the next disease and the next disease appear, as they no doubt will. So that's advance number 1. Advance number 2 is the development or the recognition of drugs that target the aging process. Now, what I'd like to point out now is that for things that target the aging process, have the possibility of pushing back all of those maladies of aging, the cancer, the heart disease, the osteoporosis, the frailty, the muscle loss, the dementia as a group at the same time. So what we're really looking at now is the ultimate in preventative medicine, which is taking medications that simultaneously prevent or delay a whole host of diseases. And here are 2 drugs that are showing the most promise right now. This is a drug that some of you in the audience may already be taking. This is metformin. Metformin looks like it has effectiveness at preventing cancer, heart disease, and dementia. And we've gone to the FDA, those of us in the field, and talked to them about approving metformin as actually treating aging. And we actually got a quite positive response. This is a drug called rapamycin. It's called rapamycin because it was discovered in a soil bacterium from Easter Island. You may recognize these Easter Island statues. Easter Island is called Rapa Nui in the local language. So rapamycin is a streptomyces bacterium that comes from Easter Island. In animal studies, this has shown to be incredibly effective, not only at lengthening life, but in preventing cancer, preventing heart disease, preventing mouse versions of Alzheimer's disease, enhancing vaccine response. There's even been human trials, which shows that you may know that older people don't tend to respond as well to vaccines as younger people, although these new ones seem like they may be exceptions to that. But rapamycin has also been shown to increase the response to a flu vaccine. So this just has a wide range of things, not a single thing. And you're soon probably going to be seeing a well-publicized clinical trial of metformin to treat simultaneously numerous diseases of aging, and the same with rapamycin. Some of you, by the way, may have rapamycin in your body. If you have a cardiac stent, rapamycin is often embedded in cardiac stents to prevent overgrowth of the stent. So now we have what I call the vampire scenario, or young blood. About 10 years ago, it was discovered that if you transfused mice, old mice, with blood from young mice, or just plasma from young mice, it had remarkable rejuvenation properties: a rejuvenated muscle, rejuvenated heart, rejuvenated brain. It even works with the blood from young people. If they take mice that have their immune systems removed so that they won't have a rejection reaction, and you transfuse an old mouse with blood from a young human, it rejuvenates all these things in a similar way. Now, there was a rush to judgment on this, and right after this work came out, some companies started selling blood from young people. In fact, I was telling my students here at UAB at the time, you people, you 20-year-olds, you're losing a huge business opportunity here, because they were selling plasma from people under 25 for $8,000 a pint. I don't know if any of you gave plasma when you were in college, but I did very briefly, and I think I got paid about $50 for it. There's a bunch of clinical trials going on now, and the clinical trials are using plasma from young people, but there's also a ton of research going on trying to identify what exactly it is in young blood that's so beneficial. And a group from Harvard not too long ago came out with a hypothesis for what they thought it was, but that hasn't stood up. But there's something in that blood, and eventually we'll figure it out. And there may be something in the blood from older people that's faintly toxic too, that needs to be removed. So there's a huge amount of research going on, and at least a half dozen companies that have been formed, startup companies, to explore this further. Next are what's called senolytic drugs and supplements. One of the things that we've discovered over the last few years is that a lot of these treatments, to be really effective in our animal models, don't have to be started when you're in your 20s or 30s. Some of these can be started in your 50s and 60s and 70s and still have substantial health benefits. One of the things that happens in your body is you gradually accumulate cells that have been called zombie cells. They're senescent cells. These are just cells that have stopped functioning and have become toxic. And we've now developed drugs called senolytics that actually will go in and remove those cells. And those are some of the treatments that can be the latest in life. And again, for certain diseases, these have already shown a great deal of promise. And there's a tremendous amount. There's at least 18 clinical trials going on with senolytic drugs now. So there's a picture. And these are combinations of drugs that are used, repurposed, and also some supplements that can be gotten at your local pharmacy. And the last one I want to talk about is the reprogramming of cells. This is a picture of Shinya Yamanaka, who made a discovery and got a Nobel Prize in a 6-year time frame. That never happens. Usually people get Nobel Prizes 20 or 30 years after they've made his discovery. What he discovered is a way to turn any cell, a skin cell, a kidney cell, a lung cell, into a stem cell that can then be transformed into any cell type in the body. That's really quite remarkable. And ultimately what they think will happen is that we will be able to have a small biopsy taken or a little blood. Someone will take a white blood cell, turn it into a brain cell to treat our Parkinson's disease, turn it into a heart cell to replace some heart cells that were damaged. That stuff is all very much in the future, but already David Sinclair at Harvard University has used this technology to replace an optic nerve that they purposely damaged in the eye of a mouse. So they purposely destroyed the vision by clipping the optic nerve in a mouse. Usually if that happens due to an accident or something, you're blind forever after. Using the Yamanaka factors to rejuvenate this nerve and make it grow right back into the eye and restored that mouse's vision. Now that was only a mouse cell and it was only recently done, but on the other hand, it shows the way that the future is headed. And I'll just give you a bonus. This is number 6. There is an international organization that doesn't want to be identified yet, but probably in the next month or 2, you will hear about this. They have proposed that they will be giving $1 billion with a B dollars per year to geroscience research. And that is going to accelerate the progress in the field dramatically. So $1 billion per year. Now, so it's time for everybody in the audience to start thinking about this. What if I had an extra decade or 2 of health that I didn't really expect to have until recently? What would I do with that? How would that affect my life? How would that affect my plans? I actually did a little TEDx talk on that topic that I thought I'd put a link to here in case any of you are interested in hearing what I thought about it. So thank you for your attention. I hope we have some questions. I'm glad to stay and answer them.
We will definitely have more questions coming in. I do have a few already. Let's go ahead and start off with, and this one has been answered by perhaps one of your colleagues, but is there ongoing research at UAB on how exercise affects aging and all of these conditions strongly related to aging?
Yes, that is a question, and that's something that's a central focus of research at UAB. And one of the most interesting aspects of that research has been the impact of exercise on the brain. You know, it's not an obvious connection between the muscles and the brain, but what we're discovering here at UAB, and like I said, a number of people working on this, is that the muscles, when they exercise, actually release these chemicals that get into the brain and actually seem to be rejuvenating the brain. So that's something I think very few of us expected to discover, is some direct muscle-brain connection. But we're identifying exactly what those chemicals are. so that ultimately maybe people won't have the fun of exercising before they get the cognitive benefits.
Another question is, can you give us a little insight into your thoughts on the financial effects of drastically extending lifespan?
Yeah, the financial effects are dramatic in two ways. In one way, the people that hate to hear me give this talk are people in work for the Social Security Administration, because they're already thinking, when Social Security was came into being in 1935, the life expectancy at 65, which was the retirement age, is exactly the same as the life expectancy today at age 75. So, Social Security is having to provide longer and longer and longer financing. Ultimately, something's going to have to give there. The other part of that, though, and the important is how people manage their money. You know, people manage their money because they think they're going to die when they're 80 or 85. That's no longer the case. And in fact, there are financial organizations that are developing just to help people plan that can basically give you an estimate for your expected length of health and help you plan financially for that. That's a whole new field of finances, and I'm a scientist, so I know zero about finances, but I do know that this is an issue that people in the finance industry are thinking about and are beginning to address.
To go off of that, is the United States or even the world ready for all of this, for the influx of people living longer?
Yeah, that's a very good question, and it's one that I've thought a lot about. So here's the first way I think about that. There's a very famous Nobel Prize winning physiologist named Elie Metchnikoff, and in 1907, somebody asked him, "What are we going to do with all the older people?" And that was at a time when life expectancy in Europe, he lived at Paris at the time, was 50 years old. And he said, "I don't know, I'm beside myself. I don't know how we're going to survive with all these old people." And that was almost 115 years ago. We've muddled through. So my thought is we'll figure it out if we don't assume that old people are going to be ill people. If we figure maybe we can take advantage of their wisdom that they've accumulated. And let me tell you, everything, if you study aging, everything goes down with age, except for one thing that doesn't, and that's wisdom. Wisdom is the one thing that psychologists find again and again and again increases. So if older people become healthier, you might imagine that we'll be able to take advantage of their accumulated wisdom to make life even better.
And I may butcher these next words because they're longer, but what do you think about taking nicotinamide or mononuclear chloride?
Yeah, so that's a sort of a trendy thing. What those are things that are precursors of what are important chemicals in making your metabolism run. And they're very promising, but we're not there yet with those. You can buy them online. In fact, for the aging class that I'm teaching, what I wanted to do is I wanted to talk about these, and I went online so I could get some photos of some of the supplements. And now I can't hardly get on the internet without advertisements for these things popping up all over my screen. But again, it's not quite ready for prime time. There, just in the last month, a paper came out in mice where they'd given these supplements for life and found no impact on longevity at all. That's not the last word. And you could have things that increase health, but don't increase longevity. But it's an interesting area of research. It's just, I wouldn't rush out and start taking it at this point.
So it seems that there are few geriatricians. So how do we incentivize medical students to become one?
It has to do with the way that we finance healthcare. I mean, that's one of the issues, is that geriatricians, which are of course needed more and more and more and more, and will be, it's not a highly remunerative subspecialty in medicine. And so if people, go into geriatrics and drive Priuses, they're looking at their friends in surgery driving Maseratis and Ferraris. So I think this is something that's got to change, because we have to change in some fashion the way that we finance our medical care. And when that changes, my guess is as soon as it's a reasonably financially rewarding subdiscipline, more and more people will go into it, because medicine is becoming geriatric medicine, essentially. The less than 2% of people get really sick and die before the age of 50 anymore. So basically medicine is about 50 plus.
What is the relationship of body weight and lifespan?
Complicated. It's very complicated. So if you just look at the epidemiology, how heavy are people and how long they live, it turns out that there's a pretty broad range of body weights that people seem to live about the same time. Being too thin seems to be disadvantageous. And of course, being too obese is disadvantageous. One of the interesting things is there's some evidence that being lean, exceptionally lean, is beneficial when young, but being a little bit heavier may be beneficial when old. So you don't get the same answer when you're talking about 30-year-olds and when you're talking about 70-year-olds. It's complicated. It's also complicated because we know that there are certain advantages of eating less. And there's a whole group of people called the Caloric Restriction Society, or the cronies, who eat very little. They're exceedingly thin. They would be considered too thin by most medical professionals. They're doing that because they think it's really healthy. I would not advocate anybody that do that, because I've spoken at a couple of their international meetings, and it's painful. It's painful to watch these people that are freezing to death in a 75-degree room because they have no body fat whatsoever to keep themselves warm.
Where can we learn more about senolytics, what they are, and then the data on role and dosing of metformin?
A good website for this kind of things is the organization that I'm the senior scientific director for, the American Federation for Aging Research. On their website is just a cornucopia of information, and that's afar.org, AFAR.org. They have no financial interests in any of these things. They just try to get the best information out there. That's a pretty good one-stop place. And it will also have links to all kinds of other places where you can learn more about Senolytics.
What over-the-counter supplements or foods do you recommend for healthy aging, or other practical suggestions for aging gracefully?
Yeah. Newspaper reporters are always asking me at the end, well, what do you take? And in fact, I don't take any of this stuff. I'm kind of a hard-headed scientist. I want to wait till the science has tamped down every last nail. So I exercise. I try to eat a reasonable amount. I don't do any unusual diets. There are a lot of diets out there now that may have some benefits that we are just beginning to learn. And these are diets that have more to do with the timing of when you eat than how you eat. Maybe restricting the time of day that you eat. Maybe fasting 1 day a week or 2 days a week. Those things are showing a great deal of promise, and we know the biology of fasting. And fasting, short-term fasting, really stimulates a lot of defensive reactions in our bodies. So I suspect in the future there's going to be more and more and more of these diets that have various types of short-term fasts, or have nutrients that fool your body into thinking it's a fast when it may not be.
With so many different diets out there, and a lot of them can be fads, and they come and go real quick. What does science really tell you how long a diet has to be studied before knowing the benefits, especially when it comes to aging?
Yeah, I'd say this is one of the huge unknowns, and that's because humans are the most miserable study animal in the world. You can't tell them to do anything and assume they'll do it. You can't trap them all in the same cage and make them eat the same thing and go to bed at the same time. One of the reasons that we know infinitely more about mouse nutrition and its effect on health than we do about human nutrition, because they don't have any choice. They eat what we feed them. We can control everything. So I think these things have to be built up over a lifetime. I think, I think what humans should go for is what makes them feel healthy. If you're doing a diet that makes you feel healthy, there is a popular supplement that I won't name because there's no science behind it. But I was once making fun of it in a public talk. It claims to rejuvenate all kinds of stuff. And someone came up to me after the talk and said, I've been taking that for 20 years and I just feel great. And I said, well, don't change it because of anything I said. If you think it's making you feel great, it probably is making you feel great. So stick with it. So I'm a big advocate. First of all, humans are very, very different from one another. We all know that some drugs are great for me and somebody else can't even take them because of side effects. The same thing's going to be true with these drugs for slowing aging. Some of them are going to work for some people. Some of them are going to work for other people. This is why UAB is moving so firmly in the direction of personalized medicine, because we want to be able to figure out which drugs are going to be the best for this person and which may actually have some bad side effects before people have a chance of experiencing the side effects.
Do you see Senolytics only targeting the inducing mechanics that induced cellular senescence or improving the clearance of these cells because in certain cells don't have proliferate and as rapidly, and they may be detrimental than those that don't?
Yeah, so the thing with these senescent cells, that's the technical name of the cells that the Senolytics are killing, is that we don't want to just go in and kill all of those cells. Some of them actually have beneficial roles. Some of them are involved in wound healing, for instance. So we want to be able to do this in a really targeted fashion. The other thing that we're learning is that there are cells that show many of the signs of cell senescence that aren't replicating cells, that are cells like your brain cells. Your brain cells don't really ever get replaced. They don't replace themselves when they die. Same for your heart cells, same for your muscle cells. But those cells themselves can show signs of senescence, and it may be that the Senolytics are making those cells healthier without killing them. They're killing the ones that we know about, that have been highly replicative and started. I'm struggling to not get too technical here because I know I'm gonna lose the audience. The person that asked that question clearly has some special knowledge, but I don't want to simply be talking to one person.
Yeah, it's nice to practice some of the words before I actually have to say some of the words, because I'm not a scientist. I'll just admit that. So, is there any data on people living longer and the impacts to climate change?
No. In fact, if anything, it's bad news for longevity, because if you think about it, every time there's one of these horrific summer heat waves in some American or European city, the people that die during those heat waves tend to be the older people, because our ability to manage our body temperature declines as we age. And so climate change is not going to be good, nor is increasing air pollution going to be good for older people.
We've got a wellness coach and therapist who has clients who are trying to cope with the uncertainty of aging and death. Is there any resources that you can think of that we can provide them?
Boy, you know, there's a whole medical specialty called palliative care that deals with exactly this kind of things. And I know that people stereotype palliative care as something that happens in the last few weeks of life, but that's not true. Palliative care is a way to manage these anxieties about the uncertainty of the future, both medically and psychologically. And also, I would tell that person to suggest that their client might want to see a palliative care specialist here at UAB. That's an area that we're very, very strong here in at UAB.
Can you elaborate a little bit more about the timing of when you eat relative to healthy aging?
Sure. The idea is this, that our body has these certain rhythms, okay? It's, you know, our body temperature fluctuates, our hormones are secreted at certain times. We have this roughly 24-hour rhythm of our bodies. And it used to be, before we had electric lights and candles and all those things, that basically we were active at the daytime, and when the sun went down, we would go to sleep. For a number of years, I worked in Papua New Guinea, and people, you know, in these remote villages where people still hunted with spears and arrows, and they had no electricity. And that's exactly the way that life was. When it got dark, they went to sleep. When it got light, they woke up. And the idea is that our body has been designed to thrive with those rhythms, and that if you eat in sync with those rhythms and you reduce the timing of meals, you know, don't eat until 10 o'clock at night. It's called time restricted feeding, and it's trying to restrict your diet to hours of the day that humans, you know, millennia ago would have been eating in, and to not eat outside those hours. And there's quite a bit of evidence emerging that there are some health benefits of that. Of course, if you restrict it, you're also going to eat less. That's an assumption too. But that's the idea. So I have to tell you this, before I got into science, when I was a lion trainer, I got the idea that I could be more efficient. I was trying to write Hollywood screenplays at the time as well. And I thought, I'm going to make the week 6 days. I'm going to do this because I'll be more efficient. All I need to do is stay up 18 hours and sleep 10. And that lasted for about 3 days. And, you know, I just didn't understand that our bodies are not designed to do that kind of stuff. And I actually stopped it after 3 days because I was getting so irritable. I figured I was going to do something and one of the lions was going to kill and eat me because I was being so obnoxious. But, you know, our bodies really are designed to function in the daytime, not so much in the night. One of the problems that people are having with insomnia now probably have to do with all those lights that they're looking at, you know, until late at night.
So is yoga a good exercise to slow down aging?
I have to say, I don't know about that. I have heard that before. I have never seen any rigorous studies of it. It seems to be great for relaxing, and relaxing is very good for psychological health. So it's a perfectly plausible idea to me. I just don't know of any hard scientific evidence to back it up.
What are your thoughts about stem cell treatment and aging and of aging and illness?
Stem cell treatments are not there yet. They will be. But right now, there's just not sufficient support of their effectiveness. But again, this is an incredibly hot area of research. There's going to be some areas that it has an impact on first. I think probably some of those areas are diabetes and Parkinson's disease, because we know what cells need to be replaced exactly. Ultimately, I think the stem cells are going to be the key to a lot of new therapies. I just don't think we're quite there yet. We don't have enough control over the situation.
And that makes plenty of sense. I'm dropping the two links that you had mentioned, the afar.org and then the TED Talk on YouTube, into the chat. So for people that are interested in those, they can have those resources. Dr. Austad, thank you so much for taking time to be a part of today's webinar. And you even got a comment, somebody loved your tie.
Thank you, Greg. It's been a great time, and I hope anybody who has any questions will feel free to shoot me an email. I'm happy to always to talk to UAB alums.
Thank you again. And for those in attendance, a recording of the webinar will be available on our website either late today or early tomorrow. Now, with more information about the UAB Office of Planned Giving and how they can help you, I'd like to turn things over to Kimberly Kopic. Once again, Kimberly.
Great. Thank you, Greg. Thank you, Dr. Austad, for that wonderful talk. You've given us a lot to really think about. My job at UAB is to help people facilitate estate gifts to the university. I'm the Senior Director of the Office of Planned Giving. A planned gift can help you make a powerful and lasting difference to the UAB programs that mean the most to you. Planned gifts offer creative, flexible strategies for your estate and charitable planning. These techniques make use of legal and tax strategies to best suit your unique situation and help you accomplish your personal and philanthropic goals. Some types of planned gifts allow you to maintain control and flexibility over your assets today while supporting UAB in the future. Others allow you to obtain an annual income and an immediate tax deduction. And still others allow you to reduce or eliminate capital gain tax. The UAB Office of Planned Giving is here to help you accomplish your philanthropic goals through a legacy gift. Reach out to us today to learn more about these types of gifts and to find out whether one may be a good fit for you or a loved one. Thank you.
And thank you, Kimberly. And there you see uab.planmylegacy.org if you want to reach them. So don't miss out on upcoming virtual events. On May 6th, we are hosting What's Next on Your Financial Checklist with Elizabeth Turnbull. Through this webinar, we will look at how retirement options like IRAs and other tax-deferred plans can help you meet your goals. Then on May 20th, join us for The Arts as a Tool for Healing and Wellness. Elizabeth Vanderkamp and Kimberly Kirkland will explore how the arts can enhance health during a hospital stay as we age and in a community setting. And on June 24th, celebrate the success of this year's class of UAB Excellence in Business Top 25 Award winners. Register or find out more about all of these at alumni.uab.edu/events. And there's still time to show your support of student scholarships. Our 15th annual scholarship run presented by Viva Health is virtual this year. The virtual run starts tomorrow and it goes through Monday. Registration for our 5K, 10K, and non-running options are only $35. You can register at alumni.uab.edu/run. And just for registering, you get a medal as well as a t-shirt. You can't beat that. 5K, 10K, non-running option, alumni.uab.edu/run. Looking for an alumni podcast? Check out UAB Green and Told. Episodes drop every other week and feature members of the UAB community. You can find the podcast on Spotify and Apple Podcasts or visit alumni.uab.edu/green and told. Be sure to stay on top of all things alumni on social media. We are UAB Alumni on Facebook, Instagram, and Twitter. You can look us up on LinkedIn by searching UAB Alumni Career Community. Finally, if you want more information about us, the National Alumni Society, visit us at alumni.uab.edu or just simply email it's not a website, it's an email, alumni@uab.edu. So once again, thank you so much for joining us from Pakistan to snowy Ohio. We appreciate you joining us for today's discussion with Dr. Stephen Austad. Have a great afternoon and go Blazers.